Let's say that I wanted to convert 4.16 miles to millimeters. 4.16 miles to millimeters. So I want to know how many millimeters are found in 4.16 miles. Would I end up with a really big number or a really small number here?
Really big number.
Really big. Millimeters are teeny tiny units, right? And mile is a really big unit. So I am going to end up with a really big number. Let's walk through our path to get from miles to millimeters. What do we think?
Miles to feet to inches to millimeters.
Miles to
I think
feet.
you go feet to meters to meters to micrometers.
Feet to meters to millimeters. I would agree with that.
Oh,
Okay, I would agree. You could also go... You could go miles to kilometers if you know that direct conversion. Then you could go kilometers to meters to millimeters. Do you know how many kilometers are in a mile?
2.2.
No, that's pounds in a kilogram. 1.6 kilometers are in a mile roughly. Because you think about it, what's a 1 mile on the track?
4 laps, 400 meters, 1,200 meters, 1,200 meters.
Nope, that's 3 laps. 1,600 meters is roughly a mile. So that would be the same as 1.6 kilometers. Okay, so you can use that conversion if you want also. But this would be the path I'd probably choose as well. So let's go ahead and map that out. We're going to always start our T-chart with what we know. We always start our chart with what we know. Okay? I want to get rid of miles. It's currently in the numerator, so it needs to go in the denominator. Right? And we said we're going to go miles to feet. Do you know that conversion? Do we have that one memorized?
5,280.
Yep. 1 mile is equal to 5,280 feet. Did anybody? All right. Then I'm going to get rid of feet and go to meters. What's our conversion between feet and meters? 1 meter is 3.28 feet. And then we're going to go meters to millimeters, right? I'm always leading with my units, and then I put in my numbers to make them true. So I'm going to say how many, which one of those is the bigger unit? Meters. So meters gets the 1, and there's 1,000 millimeters in 1 meter. All right, and so then what's my rule for doing the actual math? Multiply across the whole top, divide by the whole bottom. So I need you to multiply across the top, hit enter, then divide by whatever is on the bottom. We already said we think we're going to have a really large number here. I would agree. I rounded mine at the end here a little bit. 6,696,585.4. What would my unit be? Millimeters. Good.
I
ran
did
out
a
of room.
different path, and I got something basically yours.
Okay, good. That's perfectly fine. All right, we're going to start today with density. Density is considered an intensive property of matter. Tell me, what does that mean?
It means it's like
You have to test it.
it's like real.
I would agree that it's real.
It doesn't show.
There we go. It does not depend on the amount of matter present. Density is a property that doesn't change whether you have 1 molecule of it or 1,000 molecules of it. The density of that compound or that element or whatever it is will remain the same. So it is intensive. Density is always the same regardless of the size of your sample. The equation for density is mass divided by volume. Density is equal to m over v. D is equal to m over v. Is that familiar to you? Have you heard that equation before? Density is equal to mass over volume. Typically, what do you think mass is measured in? Grams. I would agree. And what's volume typically measured in? Liters or milliliters. And so the units for density are most often grams per milliliter, or maybe kilograms per.
I don't know how that happened.
So our density units are either going to be grams per milliliter, grams per centimeter cubed, kilograms per liters. It's some sort of mass unit divided by our volume unit. The only thing that's really important in this equation is that your units are consistent. So let me talk through what I think that means. Okay, if my density, I'm just going to make up a number right now. If my density is 14 grams per milliliter, and my mass is given to me in kilograms, is that going to work? No, I have to convert that to grams so that it matches the unit that my density comes in. Okay, so if my unit is grams per milliliter and my mass is given in kilograms, I need to convert that to grams, and then my volume would be measured in milliliters. So the units have to be consistent within this little equation, right? Grams per milliliter needs to be the same unit that's going to be found on the left-hand side. Okay. What density shows us is basically how compact our matter is. Does anyone know what's the density of water? What's the density of water? It's 1. 1 gram is equal to 1 milliliter. 1 gram is equal to 1 milliliter. So when we're talking about float or sink, we're really talking about densities greater or less than 1, right? If something has a density greater than 1, what will happen to it in water? It will sink. Okay? If we have really dense matter, that just essentially means that our matter is really close together, right? It has a lot of mass in a very little area or little space. And if it's not very dense, that means our atoms typically are farther apart from one another. Okay, so they've got a little bit more space to spread out. Let's practice here with density. Determine the density of an object that weighs 16 grams and has the volume of 0.35 centimeters cubed. What's this unit the same as? Cubic centimeters is the same as what? I gave you this conversion in our slides earlier.
It's the same as an inch. Wait, no.
This is a volume unit. It's the same as 1 milliliter. A centimeter cubed, a cubic centimeter, is the same as 1 milliliter. So that volume is identical. 1 milliliter is equal to 1 cc. Remember, did we talk about cc and where we see that unit being used? In the medical field, that's right. Okay. It's the same as milliliters. So if we ever needed to convert this to milliliters, it would just be 0.35 also, right? It's the same value. But let's go ahead and find our density here. We said that density is equal to mass over volume, which means I'm just going to plug in my numbers, right? Density equals 16 grams over 0.35 centimeters cubed. Does that cubed mean I need to do anything with the number?
No.
It does not. It only is the unit, right? It's just part of the derived unit for volume. Length times width times height is like taking the volume of that cube, okay? So now I'm going to plug it in my calculator. I'm going to expect to get a pretty big number because I'm taking a big number divided by a small number, and I get 45.71 grams per centimeter cubed. Right? My units have to come directly from my equation units. Grams, centimeters cubed. Okay. All right. A certain compound has a density of 3.21 grams per milliliter. If I have 24.8 grams of the substance, what's my volume? All right, so this time I'm given density. I like to kind of make a list over here of the variables I do have. 3.21 grams per milliliter. It says this is my mass, 24.8 grams. And I'm trying to find my volume, so I'm going to come over here and label that as my question mark. That's really what I'm searching for. Do we feel comfortable knowing that grams is going to be equal to our mass, right? That being able to pick out that number from our problem? It's being measured in grams, so that has to be our mass, okay? So now I'm going to come plug that into my equation. Density equals mass over volume, so 3.21 grams per milliliter equals 24.8 over my volume. Now, how can I get volume by itself? Right? I want to have volume by itself, and it needs to be in the numerator. Right? I want volume by itself in the numerator. Yeah, Christina, what do you think? Multiply by V. Okay, so multiply by V. Whatever I do on the right-hand side, I also need to do On the left, we agree with that? So that means that cancels. And then what else do I need to do? Divide this side by 3.21. Divide by 3.21. So that leaves me with volume equals 24.8 over 3.21. Okay? The algebra behind that works. But now here's the shortcut. If I'm going to solve for that variable that's in the bottom, isn't that the same as me just switching these two places?
Yeah.
Didn't we just show that the algebra makes that true? If I just switch volume and 3.21, right, that just makes our algebra go a little bit quicker. We know the reason behind it because we had to multiply by v, divide by 3.21, but we can see it a little bit quicker now if we just switch those two spots, right? And we say volume is equal to our mass divided by our density. Okay, so we can rearrange that equation to make that happen. So I'm going to take 24.8, divide by 3.21, and I get a volume equal to 7.73. What would my units be for volume? Milliliters. And how do we know that? Yeah, because our original density unit was grams over milliliters, that's where we get our volume unit from. Okay? It's got to be consistent within those three. Do you feel pretty comfortable with that?
Yeah.
All right, why don't you try the last one on your own? I think there's one more density problem. Yep, the bottom of that sheet has one more problem I would like for you to do. Oh, maybe. There we go. I have 0.32 liters of a substance with a density of 2.19 grams per milliliter. What's the mass? So I want you to try this one on your own. All right, so if I'm picking out here my volume, my density, I'm solving for mass. I notice I've got to convert my liters to milliliters, so that means I'm going to have 320 milliliters, right? Because there are 1,000 milliliters in 1 liter. So I'll say that my density is equal to 2.19 grams per milliliter. My mass is unknown. I've got 320 milliliters. So how do I solve for mass now? How can I get m by itself in the numerator? Yeah, what do we think? Just say it, yeah. Multiply by 320 on both sides. Do we need to do anything else? It's just that. Okay, so to get m by itself, I'm just going to multiply by 320. Multiply by 320. And that gives me a mass of 700.8 grams.